Hi, I'm Mackenzie Whittet, and today I'm going to be presenting about an experiment performed called What's in Water. The purpose was to identify unknown compounds present in drinking water samples that were from contaminated surface water, and to apply various spectroscopic techniques such as NMR and IR spectroscopy. NMR stands for nuclear magnetic resonance spectroscopy, and IR stands for infrared spectroscopy. Both measure the amount of electromagnetic radiation absorbed by a sample at different frequencies. The NMR equals or can show the number of peaks, and the peaks refers to the hydrogen atoms in different environments. The IR shows the different functional groups in a molecule. The Lewis structures can help show different functional groups and the number of hydrogen atoms in each molecule. The hydrogen represents the number of peaks, and drawing the Lewis structures can help narrow down the possible compounds without actually having the NMR and IR spectra yet. The unknowns were limited to 15 different molecules that were the possible unknowns. I picked methyl acetate as an example to show how the Lewis structure can help you predict the appearance of the IR and NMR spectra. Methyl acetate has two CH3 groups, but they are bonded to different atoms, one to oxygen and then the other one is bonded to a carbonyl group. The two different bonding environments cause each CH3 to produce a separate peak, which then is leading to there being two different peaks in the spectrum. The ratio would be 1:1 because of the equal number of hydrogen atoms in each group. The structure also shows how there is carbon singly bonded to hydrogens, and how there's also a carbon double bonded to oxygen, which show the functional groups that are present in methyl acetate. The procedure was performed using the NMR spectra Anatazi Instruments EFT90, and the IR spectrum was obtained using the Omnic software system. For one of my unknowns, there were revealed to be 3 major peaks once I obtained the NMR spectra at 1, 2, and 3 ppms, which then shows a ratio of 3:2:1. Then, using the NMR table, you can eliminate all the other compounds that don't have the ratio 3:2:1 and 3 peaks. After doing that, you can see that the only two compounds that have both of those criteria is ethanol and ethyl formate. The IR spectra then shows 2 major peaks at 3312 and 2972. Oxygen to hydrogen functional groups is roughly between 3500 and 3100, and the absorption rate for carbon and hydrogen singly bonded is between 3010 and 2800. This then shows how there are only OH and CH functional groups present in this unknown molecule. Since the NMR table narrowed down the possible molecules to be either ethanol or ethyl formate, I was able to compare the functional groups of those two compounds, and I was able to find that ethanol has the functional groups that was found using the IR spectroscopy results, and it corresponds with both of the spectras obtained. This is the structure of ethanol, and it shows how the 3 different bonding groups of hydrogen equals the 3 different peaks that we found earlier, and it shows the ratio 3:2:1 that was found using the NMR, and it corresponds with the hydrogens in each of the groups. You can also see the different functional groups that were found using the IR spectra. Some environmental effects is ethanol can negatively affect aquatic life if it enters or contaminates surface water. It can affect the health of fish and other organisms that are in that water, and it can lessen the oxygen in the water, which then affects the water quality, and this effect can lead to toxic algae blooms, which then affects the wildlife that are consuming the water, which eventually affects the ecosystem. Some human health effects from ethanol is it can evaporate easily, so if the fumes are inhaled, it can lead to headaches, dizziness, or even respiratory problems. The ingestion of ethanol can cause serious damage to your organ systems and cause nausea and vomiting and other symptoms. In conclusion, this experiment provided valuable information about NMR and IR spectroscopy. I was able to identify my unknown compound, which was ethanol, and it demonstrated the effectiveness of spectroscopic techniques when identifying compounds, even if they're unknown, in contaminated water samples. And here are my references.